Believe it or not, the future of research is already here, and it's being powered by this incredible team-up of AI and quantum computing. Today, we're going to unpack how this powerful fusion is creating a whole new class of tools that are about to completely redefine scientific discovery as we know it. Okay, so let's dive right in. First things first, what exactly are these revolutionary tools we're calling quantum copilots? At their heart, they're intelligent assistants. Think of them less like a tool and more like a partner. A partner that bridges the gap between a scientist's brilliant ideas and the just mind-boggling power of a quantum computer. They're fusing the AI we've all gotten used to with the unique muscle of quantum systems. So what does this partner actually do all day? Well, a whole lot. A researcher can literally just ask the copilot to whip up some quantum code or help them find a bug that's been driving them crazy. It can help design ridiculously complex quantum circuits, tune algorithms so they run perfectly, and even chew through raw data and spit out a summary of the key findings. It really is a hands-on collaboration. And look, this isn't just some far-off theory. These tools are being built and rolled out as we speak. So let's take a look at who's actually making this happen, from the big tech companies to the cutting-edge university labs. The race to build the best quantum copilot is definitely on. And as you'd probably expect, the usual suspects are leading the charge. You've got Microsoft, you've got IBM, and you have a really interesting specialized company called Terra Quantum, all developing their own powerful platforms. What's really cool is how each company is taking a slightly different angle. Microsoft's Azure Quantum Copilot, for instance, uses GPT-4 to help people get the hang of its quantum language, Q#. IBM is plugging its Watson X AI into its QSkip platform to help with circuit design. And then Terra Quantum is going for ultimate accessibility with a no-code platform where you can build models with just plain text. And this quote just hits the nail on the head. We're seeing a massive shift. The new interface for quantum computing is becoming, well, just talking to it. Instead of needing to be a programming genius from day one, a chemist or material scientist can just describe what they want to do in plain English. It's a game changer. But this revolution isn't just happening in corporate R&D. Oh no, the academic world is pushing the boundaries even further, asking what happens when these copilots get to be a little more autonomous. And this is where things get really wild. You've got projects like Automia, which is designed to walk a researcher through an entire complex simulation, step by step. Then there's QCopilot, which actually uses a team of AI agents to design and debug quantum sensors. And the big one, the conceptual framework of quantum agents, that's imagining a future of truly autonomous systems that could run entire research projects by themselves. Okay, so we have these incredible tools. But what does that actually mean for the day-to-day work of science and research? This is the crucial part. This is where you see just how much of a game changer this is. I mean, just look at the difference here. The old way, you needed deep, specialized expertise, and you were stuck in these super long cycles of trial and error. With a copilot, that barrier to entry gets way lower. You can iterate incredibly fast, and suddenly your classical computers and your quantum hardware can all work together seamlessly. It all really boils down to three huge benefits. First, you've got speed and scale. You're automating tedious work so everything moves faster. Second, you have democratization. You're opening the doors to way more people with great ideas, not just the coding experts. And third, that hybrid integration, finally getting all your computers to play nice together. Just let that sink in for a second. Weeks to hours. Think about what that really means for discovering new drugs or finding new materials to capture carbon from the atmosphere. We're talking about unlocking innovations that were impossible before, simply because they would have taken too long. And hey, we're not just talking hypotheticals here. This is real. The QC Pilot research platform got a jaw-dropping 100 times speed up in a real-world atomic cooling experiment. It even figured out on its own when the experiment settings were off. That's not just theory, that's a concrete, game-changing result. Okay, but let's be real. No revolutionary tech comes without a few bumps in the road. And to get this right, there are some pretty big challenges we have to navigate, and navigate carefully. You've got 4 big things to think about, and they're all connected. First, Reliability. AI can hallucinate. It can make mistakes, so an expert has to validate what it produces. That ties right into domain expertise. These tools can't just operate in a vacuum. Then there's data scarcity. Good AIs need good data to learn from, and high-quality quantum data is still pretty rare. And finally, ethics and transparency. We have to know how these things are reaching their conclusions.
And this brings us back to what is maybe the most important thing to remember. There's a reason they're called co-pilots, not autopilots. They are here to assist, to augment, to supercharge the human expert, not replace them. The scientist is still and will always be in the pilot's seat.
All right, let's look ahead. What does the roadmap for this tech look like? Because the timeline for these co-pilots breaking out of the lab and into the real world is, well, it's surprisingly fast. Things are going to move quickly. Over just the next couple of years, we'll see the tools from Microsoft and IBM become common, while Terra's no-code platform gets tested more widely. And at the exact same time, those more autonomous academic projects like Atomia will be getting their first trials. It's an incredibly fast track from the assistants we have today to the powerful agents of tomorrow. So when you boil it all down, what's the big picture? It's this. We are right at the dawn of a brand new era of discovery, one that's going to be defined by this powerful, close collaboration between human creativity and artificial intelligence. And that partnership is going to change everything about how we innovate. And that leaves us with one last, really exciting question to ponder. With this incredible new partnership, this fusion of human insight and machine intelligence, what's the first huge problem humanity is going to solve? In medicine? Climate? What do you think it will be?